to the chapter Reflection of Light by Different Surfaces. This slide presents the overview of the chapter. By the end of this chapter, you will be able to explain the formation of an image by a plane mirror, describe the characteristics of an image by a plane mirror, explain reflection by curved spherical mirrors, explain the formation of an image by curved concave and convex mirrors, describe the characteristics of an image by curved concave and convex mirrors. Draw the ray diagrams for concave and convex mirrors. Derive mirror formula refractive index of prism. Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to learn more. In lower classes, we learned that a shadow is formed when a source of light, an opaque object, and a screen are placed in a straight line. Light always travels in a straight line. This principle is called the rectilinear propagation of light. The angle of incidence of a light ray incident on a surface is equal to angle of reflection. This is the first law of reflection. The incident ray, the normal, and the reflected ray lie in the same plane. This is second law of reflection. Now, can you answer these questions? Why does the shape of our image changes in some mirrors? Why does an object appears to be inverted with respect to its image in a mirror? Is it possible to focus sunlight at a point using mirrors instead of magnifying glass? What is the explanation behind the first law of reflection? Does first law of reflection hold good for curved surfaces too? Let us try to answer these questions and learn more about the reflection of light. Plane of reflection. When the pins fixed at P, Q, R, and S are at same height, then the plane containing the incident ray, reflected ray, and the normal is called the plane of reflection. Formation of an image by a plane mirror. The reflected rays of an object from a plane mirror are geometrically extended backwards to meet at a point to form the object's image. Let us use geometric models to understand this concept in details. Consider a point object O in front of a mirror. Its reflected rays can be geometrically extended back to meet at point I. From the image, the reflected rays seem to appear from the point I. This is why I is the point image of the point object O. Similarly, consider an object O' before the mirror. The ray diagram of its incident ray, reflected ray, and normal can be drawn using laws of reflection. The reflected rays from O and O' when geometrically extended back, meet at points I and I' respectively. They are the point images of the points O and O'. The rays coming from the middle section of O' form the image I'. The image formed on the plane surface of a mirror has certain characteristics. They help us in better understanding the phenomenon of reflection. Let us learn about the characteristics of the image in the next section.
your child. Win free education for life. Book a free coding class with White Hat Junior. Take it.
Click each tab to know more. Size. The sensing of an object's image size depends on the angle made by the image at the observer's eye. From the geometric model, the object at O appears smaller to the observer 2 when compared to the observer 1. It is because the light rays coming from the object make smaller angle at his eye due to the longer distance compared to observer 1. For the same reason, the size of the image decreases when it is moved towards the eye and away from the mirror. As the distance of the image from the mirror increases, the angle formed by the image at the observer's eye decreases, making the object smaller in size. Distance. From the above discussion, we also learnt that the distance of an image from the mirror is always equal to the distance of the object from the mirror. It takes place because our brain senses the image as a back extended reflected ray of the object inside the mirror. From the geometric model, consider observer standing in front of a mirror. Light rays from the right ear of an observer falls on the plane mirror and gets reflected. But when geometrically back extended, the reflected ray seems to appear from the left ear inside the mirror. Hence, the right ear of an observer appears inverted as his left ear before a plane mirror. Observe the following animation to learn more on inversion of an object's image. After learning about reflection of an object from plane mirror, let us now learn about reflection of objects from curved surfaces. Difference between real image and virtual image. The following table shows the differences between the real image and the virtual image. Spherical mirrors. The main area of focus is the angle made with the normal at the point of incidence. If one can decide the normal and find the incident angle of any surface, it is possible to determine the angle made by the reflected ray. A normal at any point on the plane surface can be easily found out, but for a curved or uneven surface, it is not straightforward. Note: a mirror with its reflecting surface bent outwards is called a convex mirror. A mirror with its reflecting surface bent inwards is called a concave mirror. Let us learn how to draw a normal on curved surfaces, bent inwards and outwards respectively. Activity: finding the normal to a curved surface. Take a small piece of rubber, fix some pins in a straight line on it. All the pins will be perpendicular to the surface of the foam. They are the normal for any incident ray at their point of fixation and help in obtaining the reflected ray. Now, bend the rubber inwards. The pins representing the normal at their respective points of fixation tend to converge at a point. For a convex mirror, this point of convergence of the normals is called its center of curvature C. When the rubber is bent outwards, the pins representing the normal tend to diverge from each other, but they appear to emerge from a single point. For a concave mirror, this point is its center of curvature C. Note: the fact that a radius to a point on a circle is always perpendicular to the tangent passing through that point is used in finding the normal to the curved surface. Any line drawn from a point on a curved mirror to its center of curvature is the normal at that point. To better understand reflection of parallel incident rays by spherical mirrors, let us define some of the physical quantities.